Hi, I'm Bailey with my math experts, and today I'm going to help you solve the following problem. What is the completely simplified equivalent of 2 divided by 5 plus I? So initially you might be kind of confused by this question because this already looks pretty simplified. There's not any immediate things that we can like cancel, for example. But what they mean by simplifying this here is rewriting it in such a way that we don't have an I in the denominator. So just like you might have heard before that mathematicians don't really like it when there's like a square root in the denominator, and so you have to rationalize that by multiplying by, in this case, root 5 over root 5, which would turn it into, hey, look at that, that's root 5 squared, which is just 5. Hey, look at that, now our square root is out of the denominator. Very similar process here. We're going to have to do something. We're going to have to multiply by something that gets this I out of the denominator. So unfortunately, it's not as simple as just multiplying by I over I, because let's see what's going to happen if we do that. Well, we're going to have to kind of distribute this I, and we're going to get our denominator is going to be 5I plus I squared. I squared, of course, is -1 because it's the square root of -1 squared, which is -1. So this ends up working out, but we still have a 5I in the denominator. So that doesn't entirely solve our problem in the way that we would hope it might. So instead, if you want to cancel out an I in the denominator, you're going to have to use something called the complex conjugate. And basically what the complex conjugate says is if you have something, let's say a plus bi, the complex conjugate to that is going to be a minus bi. So the real part stays the same, no change there. It's just the imaginary part changes signs. That's the only thing that changes with the complex conjugate. And if you multiply a complex number by its complex conjugate, the imaginary parts cancel out and you're left with just a real number at the end of the day. This is a pattern you might notice is going to look kind of like a difference of squares. Think about if you multiply these two things together, what you're going to end up getting is a squared minus bai plus bai minus b squared, I squared. This stuff's going to cancel out. You're going to have something squared minus something squared. This is a difference of squares. So all that Algebra 1 knowledge about factoring and differences of squares does have a reason. There's a reason you learn it, and that reason is complex conjugates. So let's just go through this example here. Let's go 2 over 5 plus I, and we're going to multiply by the complex conjugate to 5 plus I, which is, like I said, we're just making the imaginary part negative. So we're keeping our real part 5, making this positive I a negative I. And then, of course, we don't want to change the actual value of our original. So we have to do this on our numerator as well, so that we're multiplying by something that simplifies to 1 at the end of the day. And now we're just going to work this out. Whenever you have things that are being added or subtracted in numerators or denominators, I always just go ahead and put them in parentheses because it's really easy to forget to distribute stuff if you don't put them in parentheses, in my opinion. So here we're going to have, it looks like 10 minus 2i in our numerator. And we're going to have 25, 5 times 5, minus 5i, plus 5i, minus I squared. Okay? And you might be thinking, okay, let's cancel out this minus 5i and this plus 5i. We can definitely do that. Let me get rid of these guys. Cool. So now we just have 25 minus I squared. And now you might be thinking, hey, wait a minute, that's not any of the answer choices up here. So what gives? And I alluded to this earlier, but we can actually continue simplifying I squared. I squared, definition of I, right? I is just square root of -1. It's not like X. It's not like some random variable that we don't know what it is. We do know what I is. Has a definition. It's the square root of -1. So if we take the square root of -1 and we square it, then what's going to happen is that the square and the square root are inverse operations. They're going to cancel each other out. So that's just going to turn into a -1. So this I squared we've got going on here is just going to turn into -1. So what we actually have here is 25 minus -1. Well, hey, that's just 26, right? Let me give us some more room here. 10 minus 2i over 26. And now you might be looking at your answers and thinking, hey, well, that's still not one of my answer choices. What the heck? We're almost done. We have literally one step left. And that is to cancel some things out. If I were you, this is how I recommend doing it. Because there's a lot of kids get very willy-nilly with the canceling. So this is what I recommend doing. I recommend, again, if you ever have things being added or subtracted in fractions, put them in parentheses to indicate to your brain those guys are together. You can't split them up. So what I'm going to do is factor out a 2 out of my numerator here, so that this is going to be 2 times 5 minus I over 26. And now that that 2 is factored out, I'm going to cancel here. So my final answer here is going to be 5 minus I over 13. That's the most we can do. There's nothing else we can factor. There's nothing else we can cancel. That's the simplest way to write this. 5 minus I over 13. And now that is one of our answer choices. That is C. And that is the completely simplified equivalent of this. So I'll go ahead and, I'll go ahead and zoom out here so that you can kind of see everything written out, if that is helpful to you. There you go. So I recommend writing another one of these yourself. They're really easy to write. Literally just change the numbers. Practice it yourself. There's also plenty of practice for this kind of stuff online. But do a couple practice problems by yourself, see if you're getting the idea, and then you should be good to go. So great. Thanks for sticking along with me on this one, and I will see you next time.